Today we will be discussing a square infinite grid problem. Consider that they are asking the resistance between two diagonal points in a square infinite grid. So it is A and B. If each branch resistance is 1 ohm, then what is RAB, the equivalent resistance? Here we cannot apply ladder and we cannot apply mirror, and we can say that the path resistance is not equal, because from A to B we can go like this or like this or in such infinite ways. So the path resistance in all paths is not equal, and hence we cannot apply current division rule. So here what we do is we inject a current I from into the A terminal and collect it at some infinite point, and then we inject it at infinity and collect it at B, and we add both of the values using superposition theorem. So in the first part we inject the current at I and collect it at infinity. So here we can apply current division rule, because the path resistance between A and infinity in every path is equal, because we can go in any path and reach infinity and it will be an equal path resistance. And now we can apply current division rule. At this node, when we apply I, it is being divided into 4 equal paths. So I by 4, I by 4, I by 4 and I by 4. And here I by 4 is further being divided into 3 paths. So I by 4 by 3 would be I by 12, I by 12 and I by 12. At this point again, we can apply KVL. Assume that the voltage difference between A and B is VAB dash. As the current flows from higher potential to lower potential, the voltage at A would be positive and the voltage at B would be negative. So VAB dash is I. We can say, by applying KVL, minus VAB dash is equal to I by 4 into 1 ohm resistor plus I by 12 into 1 ohm resistor. So in this loop, we will obtain VAB dash as I by 3. In the second part of the problem, we are injecting current at infinity. So at node B, we are collecting it. So the current coming out of B would be I. So the collection of this should be I by 4, I by 4 and I by 4 from 4 equal parts, so that it will add up to I. And at this point it will be I by 4 by 3. So this will be I by 12, I by 12 and I by 12. In a similar manner, here we can say that as the current flows from positive terminal to negative terminal, the voltage at A would be plus and this is minus. So now let it be VAB double dash. And VAB double dash is I by 12 into 1 ohm resistor plus I by 4 into 1 ohm resistor, which will again be I by 3. By superposition theorem, we can say that the total response in between a branch is the sum of individual responses produced by each of the element. So we can combine it and write it as I entering from A and leaving from B. So it will be sum of I by 3 and I by 3, which is 2I by 3. And we know that resistance is voltage by current, so 2 by 3 is the final answer.